Good day, I'm Maika Libradilla. Now I will give short term about Brønsted-Lowry acid and base. First are the proponent of Brønsted-Lowry theory, introduced by Johannes Nicolaus Brønsted and Thomas Martin Lowry. The Brønsted-Lowry acid and base was invented by these two scientists, which give more definition of acid and base theory. This theory is an acid-base reaction that was independently proposed in 1923. These two scientists conduct a theory about acid and base. Nya, coincidence kay ilang pag-conduct sa ilang theory kay same year and same topic ilang gi-studyan. The concept of Brønsted-Lowry acid and base is that an acid is any hydrogen containing that is capable of donating a proton to another substance, and a base is a molecule or ion that is able to accept a hydrogen ion for an acid. Also, according to Brønsted-Lowry, if an acid loses a proton, a conjugate base is formed. Similarly, when a base gains a proton, a conjugate acid is formed. A short term of Brønsted-Lowry acid and base is, para masabtan dyan nato ang iyang short nga definition, is a Brønsted-Lowry acid is a substance that donate protons, and a Brønsted-Lowry base which can accept protons. That's all.
The reaction between acid nitric acid and water, nitric acid or HNO3 donates a proton shown in blue to water, thereby acting as a Brønsted-Lowry acid. Since water accepts the proton from nitric acid to form H3O+, water acts as a Brønsted-Lowry base. This reaction highly favors the formation of products, so the reaction arrow is drawn only to the right. Let's now look at the reaction involving ammonia, or NH3, in water. In this reaction, water is donating one of its protons to ammonia. After losing a proton, water becomes hydroxide or OH negative. Since water is a proton donor in this reaction, it is acting as a Brønsted-Lowry acid. Ammonia accepts a proton from water to form an ammonium ion or NH4+. Therefore, ammonia is acting as a Brønsted-Lowry base. In the two previous reactions, we see water behaving both as a Brønsted-Lowry base in the reaction with nitric acid and as a Brønsted-Lowry acid in the reaction with ammonia. Because of its ability to both accept and donate protons, water is known as an amphoteric or amphiprotic substance, meaning that it can act as either a Brønsted-Lowry acid or a Brønsted-Lowry base.
So right now, I'm going to give you some examples in order for you to deepen your knowledge about the concepts of Brønsted-Lowry acid-base pairs. So, how can you identify Brønsted-Lowry acid-base pairs if you're given sets of reactions? So let us always remember that Brønsted-Lowry acids are proton donors, meaning they give away protons or H+. And Brønsted-Lowry bases are proton acceptors, meaning there needs to be a lone pair of electrons on an atom for it to accept an H+ or proton. So how can you identify these acid-base pairs? Let's take a look at these three examples. H2CO3 reacts with OH- to make HCO3- and H2O. So take a look at this chemical versus this chemical. What's the difference? This one has two H's and this one has 1. This one has a charge, and this one has a negative charge. So they differ by an H and by a single charge. That means H2CO3 lost an H plus to get to the other side. Therefore, this is the acid in this acid-base pair, and this is the base. So kani ang naghatag or nagdonate sa proton, ug kani ang nagdawat or nag-accept sa proton para ibalik na po niya to this. Give away a proton, get a proton, donate a proton, accept a proton. So, ingana lang siya kasimple, guys. Now, remember, the H2CO3 and the HCO3 minus here are the conjugate pairs. Okay, the conjugate pairs, itong basahan ang definition niya. Conjugate acid-base pairs differs by just 1 proton, and acid has the extra proton. So, in this case, the H2CO3 and the HCO3 minus are the conjugate pairs. Now, next, OH minus and H2O, on the other hand, also differ by a single H and by a single charge. In this case, mauni ang acid, because as you can see, na siya duha ka H's, whereas this one only has 1. Kani kay naa siya missing a hydrogen, and this one has it. This is ready to donate a proton to turn back into this. This is ready to accept a proton to turn into this. So we can see nga the one with more protons or H's is the acid in the acid-base pair. Okay? So let's proceed to the next example. HCO3 minus differs with an H plus between this one, CO3 2 minus. So they both have a CO3, but this one has an H and this one kay wala. This one has a charge of a -1. This one has a charge of -2. So they differ by an H and a plus or a charge. So since HCO3 minus is the one with extra proton, this is the acid. Okay? And CO3 2 minus is its conjugate base. So how about S2 minus and HS minus? Asa kahadari ang acid o ang base? As we can see, they clearly differ by a single proton. Right? Naadari ang extra H. So mauni siya ang carrier sa extra nga H. So mauni ang acid. And this is the base in the conjugate acid-base pair. Okay? So another example. H2O differs by just a single H to H3O+. And this has the extra proton, kinasya tulo, and this one has only 2. So that means, since nasya extra nga proton or hydrogen ion, this means mauni siya ang acid, and this is the base. Okay? How about this two? These two also differ by a single H and charge. H2O has 2 H's and OH minus has 1. So H2O is the acid and OH.
In conclusion, according to the Brønsted-Lowry theory, an acid is a substance that dissociates to release or donate protons and form its conjugate base. On the other hand, a Brønsted-Lowry base is a substance that accepts a proton and forms its conjugate acid. Therefore, acid and base reaction according to this theory both involves a transfer of proton. So in order to fully understand or easily understand the concept of the Brønsted-Lowry theory, we just need to be familiar with the abbreviation DAAB, which stands for donate acid and accept base. Before, we can say or we can determine if that substance is acid if it has a pH level lower than 7. And we can determine if it is base if it has a pH level higher than 7, or the color it's possessed if being being in contact with a litmus paper. But through Brønsted-Lowry theory, we can say that if a particular substance is acid or base depending on how they involves the transferring of proton. So if it transfer proton, then it is an acid, and if it accept proton, then it is a base. And that would be all for today's discussion. So, to assess your knowledge if you have learned something from today's discussion, I will be giving a series of activity for you to be answered. Are you all excited? I will be giving you 5 minutes to answer this following question. That would be all. Thank you.